Okay, let's get started with chapter 8. So our first section is actually going to be review from Math 95. We're going to be talking about solving linear equations, which we've already seen quite a bit so far in this class. We've been solving a lot of equations. And we'll also take another look at solving inequalities in one variable. So let's start with a definition here. And it's the definition of an algebraic expression. So an algebraic expression is a collection of constants, variables, operation symbols, oops, not operations, operation symbols, and or, so it doesn't have to have all of these, grouping symbols. And this is exactly like we've seen before. So a couple of examples here, something like 8x plus 9, or y minus 4, or a mix of variables like x cubed, y cubed over z. So here we have some constants. So like 9 here is a constant. Variables, x is our variable in this first expression. Operation symbols would just be the addition, the multiplication between the 8 and the x. And we don't actually have any grouping symbols in this one, but over here, this fraction bar is considered a grouping symbol because it groups the terms on the top and it groups the terms on the bottom separately from one another. So remember, when you're simplifying, you simplify the top and the bottom separately. That's because they're in two different groups. All right, so an equation, and this isn't really going to be much of a formal definition, but just kind of a reminder that an equation always contains, I cannot write today, contains an equality symbol. And by equality symbol, we just mean an equal sign. And remember, an expression does not. So that's kind of the one main way to tell the difference between an expression and an equation. So let's go ahead and look at some examples. All we're doing here is identifying if we're given an expression or equation. And so for these ones, these should be hopefully pretty straightforward. I'm going to go ahead and just list all 4 of them out. So I would, as I go through and list these out, write down if it's an expression or an equation, and then check your answers with mine. So number 1 here, we have 9x equals 10. Number 2, 9x plus 10. Number 3 is 3 plus 5x minus 8x plus 9. And number 4 is 3 plus 5x equals negative 8x plus 9. So go ahead and state whether those are an expression or an equation. You can pause it if you need to. But let's go ahead and go through these together. So number 1, we have an equal sign here, which means this is an equation. Number 2, there is no equal sign, so this has to be an expression. Number 3, again, no equal sign, so this is an expression. Number 4, we have an equal sign, which means this is an equation. And remember, if it's an equation, we can solve for x. If it's an expression, all we can do is simplify. There's no x equals some number at the end. It's just simplifying it down. Okay, now let's look at a couple of review problems of solving equations. And we've seen plenty of these already, so these should hopefully not be too bad. All right, so number one, we'll just do two of these. We're given 5p plus 4 times the quantity of 3 minus 2p equals 2 plus p minus 10. Now, a couple of things to remember when you're solving equations. First thing you want to do is clear the parentheses, assuming you don't have any fractions to get rid of, which we don't. So let's go ahead and distribute the 4. So we get 5p plus 4 times 3 is 12. 4 times negative 2p is negative 8p equals, and I'll leave the right side alone for now because we have some combining to do on both sides. So we'll just do it in the same step. On the left side, we can combine the 5p minus 8p, which gives us negative 3p plus 12. And remember, it doesn't matter which order you put these in. I could have also done 12 minus 3p. Just make sure that the signs are the same. So the 3p is still negative, the 12 is still positive. All right, and then on the right side, we can combine the 2 minus 10. This gives us a negative 8 plus p, or p minus 8. And now we can start moving things around. So this is where you can kind of go in just about 4 different directions. You could move the variables first, or you could move the constants first, and you can move them to 2 different sides. Normally what I'll do is I'll move the variables over to the left, just because when you're solving inequalities, having the variables on the left side makes it a little bit easier to see the answer. We'll see that a little bit more once we get to our inequalities in a second. But I'm going to go ahead and move the p's over to the left. So I'll subtract p. So we get negative 4p plus 12 equals negative 8. Now we can move the constants to the right, so minus 12 from both sides. And we get negative 4p equals negative 20. And then dividing by negative 4, we get p equals 5. So remember, the big thing for solving equations is simplifying the expressions on both sides of the equal sign first. And then we go ahead and start moving things around. Variables can go on whichever side, constants can be on whichever side, but our goal is to get the variables on one side, numbers on the other, or constants on the other. And then if you have a coefficient, we divide by that because we have multiplication in between this negative 4 and the p. And you always do the opposite of what you see. All right, so hopefully that one wasn't too bad. Let's go ahead and do another one. And because we just did that one together, I would go ahead and try this one yourself. And then check your answer with mine. So we're given 2 minus 3 times the quantity of 2 plus 6x equals 4 times the quantity of x plus 1 plus 18. So when you're solving this one, just be careful with the distribution in this one. So if we look at the left side here, we're distributing this into both of these terms. And what number are we distributing? Well, we're distributing a negative 3. Make sure you carry whatever sign is in front of that number or term. There might be a variable out in front. There isn't in this one. But make sure you distribute that sign as well. So we're going to keep this 2 in the front. Negative 3 times 2 is negative 6. And then negative 3 times 6x is negative 18x. On the right side, we can distribute this 4. we get 4 times x is 4x. 4 times 1 is 4, so plus 4 plus 18. And now think, what is our next step going to be here? Well, we want to combine our like terms, so let's combine the 2 minus 6, and we get negative 4. Minus 18x, there are no x's on the left side. Now on the right side, we can combine this 4 and the 18. So keep the 4x in the front, or you can write it at the end, and then plus 22. And now let's move all of our variables to one side, all of the constants to the other. Just like I did last time, I'm going to move all the variables to the left. So I'll subtract this 4x. So we have negative 4. Negative 18 minus 4 is negative 22x equals 22. And then, the x's are on the left, so let's move the constants to the right. So let's add 4 because it's negative. So we have a negative 22x. Make sure you don't lose that negative. That's another kind of common mistake here, is just dropping minus signs. Equals, adding these together, we get 26. And then our final step here, because we have negative 22 times x, we're going to divide by negative 22. Make sure you include that negative. And so we get x equals, now with this fraction here, 22 doesn't go into 26 evenly. I'm going to leave it as an improper fraction. If you wanted to write it as a mixed number, you could. I think with MyMathLab, it's easier to input an improper fraction. So I would just reduce this down. We can divide both of these by 2. So we get a 13 over negative 11, or negative 13/11. All right, so that's it for our linear equation examples, because we've already seen some of those. Now let's move on to linear inequalities. And remember, linear inequalities are really similar. There's just a couple extra things we have to do once we go through and solve. So linear inequalities are going to look just like linear equations, except they're going to use less than and greater than symbols. So remember, just a quick review of those. These two symbols here, we have a less than and greater than. And with the less than and the greater than, and positive infinity and negative infinity, when you're writing the interval notation, you're going to use parentheses. So this is going to be for interval notation and graphing. So remember, we're going to graph these on a number line. And then if we have a less than or equal to or greater than or equal to, with these ones, we're going to use brackets. The way I remember the difference is that these hard lines here on the less than or equal to look like the hard lines here on the brackets. So that's a kind of nice way to remember those. Now that we have that, let's go ahead and do some examples. And so for these, we're told to solve, graph, and write the interval notation. And so when you're doing these on MyMathLab, it'll say write your solution set. And if you look at the little note right below the little box where you're going to type your solution, it'll say write your answer using interval notation. That's the big thing here, is that your solution set is going to be with interval notation. So it's not the x is less than 5 or whatever we're going to get as our answer. It's always interval notation. So what I mean by that is, let's look at an example and we can kind of see. First one here, let's go ahead and do 2x minus 3 is less than -9. So just like a regular equation, we want to go ahead and add the 3 first because the variables are already on the left. And if you remember, there's only one little difference between solving an equation and solving a linear inequality. And that comes, the difference comes when we are dividing or multiplying by a negative, which we haven't done yet. We've only added a 3. So we're going to keep everything the same. We get a 2x is less than -6. Then we're going to divide both sides by 2. We're dividing by a +2, so we're still not doing anything different here. So we're going to get x is less than -3. Now, this is not the solution. Our solution is going to be the graph and the interval notation. So for the graph, I like to do the graph before I do the interval notation because I think it makes it a little bit easier to find the interval notation. I'm going to see what number we have here. We have a -3. I'll put that right in the middle. And then I'm going to put a couple numbers on either side. Remember, we go more positive as we go to the right, more negative to the left. So more negative would be -4, more positive is -2. And you can do more numbers if you want. I usually just do 3. And now we want to see if we're going to use a parenthesis or bracket. Because it's a less than, we don't actually want to equal 3. We're going to use parentheses. And then if we want to figure out which way we're shading. We want everything less than -3, so everything to the left. And then I'll put my parenthesis facing to the left. Another way you can think about where to shade, if you have your variable on this side, on the left side, then you're going to shade whichever direction this is pointing. So less than, shade to the left, greater than, shade to the right. And now for our interval notation, we're going to look at the graph and we're going to see the furthest left that we go to the furthest right. The furthest left that we go is all the way to the left. That's -infinity. Negative infinities always have parentheses. So we're going to have a parenthesis, -infinity, comma. The furthest right we go is -3, also with a parenthesis. So that's what I'll box. That's our final solution set. This is just saying any number between -infinity and -3, but not including -3. So you could go to -3.0001, but you cannot get to -3. Any of those numbers would be solutions to this inequality. Let's go ahead and try a few more of these. Number 2. -9x is less than -81. So for this one, we want to go ahead and get our x by itself. So we're going to divide both sides by -9. Because we are dividing by a negative, we want to flip our inequality. So when dividing or multiplying by a negative, it has to be by a negative. The negative is not going to be on the top of the division. So this -81 doesn't actually change anything. The -9 on the bottom does. We're going to flip the inequality. All right, so everything else stays the same. You're still using the same sign rules. Things still cancel out the same. So we get x, we flipped the inequality, and then we get negative 81 over negative 9 is positive 9. All we did was flip this, and you're not going to add in the greater than or equal to. It's still greater than. All we're doing is flipping it. All right, now let's go ahead and graph this guy. So I'll put 9 in the middle, and then I'll put 8 on the left, 10 on the right. And now we want to know if we're doing parenthesis or bracket here. Well, it's a greater than. There's no equal to, so we want to use a parenthesis. And are we shading to the right or to the left of 9? Well, we want everything greater than 9, so we're going to shade to the right of 9. So we're going to have a parenthesis, shade to the right. And now with our interval notation, the furthest left we go, we start at 9 with a parenthesis, comma, the furthest right we go is all the way to positive infinity. Always use parentheses there because we can't actually equal infinity. Okay, let's go ahead and try one that has a little bit more work to it. 2 parentheses x plus 2 minus 1 is less than or equal to 6x minus 5. Now, you know how to solve an equation. So what I would do is go through, solve this one. Just remember, if you divide or multiply by a negative, you have to flip the inequality. That's the only difference. So I would solve this one, try to graph it and write the interval notation, and then check your answer with mine. Okay, so if we go ahead and start by distributing, we get 2x plus 4 minus 1 is less than or equal to 6x minus 5. There's nothing to do on the right. We can now combine on the left. So we get 2x plus 3 is less than or equal to 6x minus 5. And now let's move all the variables to one side. I prefer to move all the variables to the left because it's a lot easier to read your inequality like we saw up here, where your variables on the left. If it's flipped around, if we had the 9 on the left and the x on the right up here, the inequality would be facing the other way. If you see the closed part of the less or the greater than symbol over here is pointing towards the 9. So we want it pointing towards the 9 if you flip them around. So you'll just want to flip it around because you still want to shade to the right of that 9. This still says x is greater than 9. But if you flip it around, this is saying 9 is less than x, which is the same thing. It's just a little bit easier to read with the x on the left. So I'm going to move the 6x back down here over to the left. So I'll subtract 6x. Even if it makes your x's or negative, it's okay because we know that we have to flip the inequality. So we get negative 4x plus 3 is less than or equal to negative 5. And again, we haven't divided by a negative yet. It's okay if we subtract. And now let's move our constants to the right. So I'm going to subtract 3. And we get negative 4x is less than or equal to negative 8. And now when we divide by a negative 4, we're going to have to flip the inequality. And we get x is greater than or equal to a positive 2. Now, if we go ahead and graph this one, I'm going to put 2 in the middle. I'll put 1 on the left, 3 on the right. Are we going to use parenthesis or bracket here? Well, we'll go ahead and use a bracket because it's greater than or equal to, and shade to the right or to the left. Well, we want everything that's greater than 2, so we're going to shade to the right. So bracket faces to the right, shade to the right. And our interval notation is going to start at 2 with a bracket, comma, we're going all the way to the right, which is all the way to positive infinity. Always use parentheses there. So you can have this kind of mix between brackets and parentheses. That is perfectly fine. All right, let's go ahead and try one more before we look at compound inequalities or three-part inequalities. This is number 4, yeah, number 4. For this one, we're given 5x minus 6 all over negative 2 is greater than 6. So for this one, you can kind of think back to what we just did in section 7.6. We have a fraction, and so in order to get rid of the fraction, we're going to multiply by the LCD. And our LCD here, we only have one denominator, it's negative 2. So now if we go ahead and multiply each term, so this fraction right here is one term, and you can put that in parentheses if you want, that's 5x minus 6. Multiply the right side by negative 2. Because we're multiplying by a negative, we have to flip our inequality. So I'll normally do that first so you don't forget to do it. Now let's go ahead and cancel things out. So let's cancel out these negative 2's. And we have 5x minus 6 over 1, so just 5x minus 6, is less than 6 times negative 2 is negative 12. And now if we go ahead and solve for x, we're going to move our constants to the right. So let's add 6 to both sides. We get 5x is less than negative 6. And let's divide both sides by 5. And so we have x is less than, now for this one, you can leave it as negative 6/5. Or you could also rewrite this as a mixed number if you wanted, negative 1 and 1/5. Either one's perfectly fine because for graphing numbers like this, they're not nice whole numbers. What I'll normally do is I will put that number in the middle. I'm going to just do the negative 6/5. And as long as you know that everything to the left is more negative, everything to the right is more positive, if you want to just do that one number in the middle, that's perfectly fine. So if we go ahead and graph this, we have everything less than negative 6/5. So we're going to have a parenthesis, and we'll be shading to the left because we want everything less than negative 6/5. And our interval notation, starting from the furthest left is negative infinity, always with a parenthesis. To the furthest right is a parenthesis at negative 6/5. All right, so the last little part of this section is on three-part inequalities. And these ones are really similar, but just like it sounds, there's going to be 3 parts to the inequality. So not just a left side and a right side, there's going to be a left, a middle, and a right. So our goal with 3-part inequalities is to get x in the middle by itself. So whenever we've solved inequalities, like the ones that we just saw over here, our goal was normally to get the x. I usually put it on the left, but x on either side by itself. With these ones, it has to be in the middle. That is the big thing here. So let's go ahead and look at some examples, and we're going to be doing the same thing where we graph them and write the interval notation. So we're going to solve, graph, and write the interval notation. Okay, so number 1 here, we'll just do a couple of these. They don't come up as often as the others. 5 is less than x minus 4, which is less than 9. Now, our goal is to get the x in the middle by itself. So you want to look at the middle and see what you need to get rid of. Right now, all we have is this -4. So we're going to add 4, not just to the middle, but we're going to do it also to the left and to the right. So what you do to the middle, you do to every single part, all 3 parts of this inequality. 5 plus 4 is 9. Bring down the less than. Now we just have an x in the middle. Bring down the other less than. 9 plus 4 is 13. And now we have x in the middle by itself. With any of these with a negative, we'll see an example, you'll still be flipping the inequalities. So keep that in mind. But for this one, there's nothing else to flip, nothing else to do here. X is already by itself. And these ones are really nice to graph. So what you're gonna do is you're gonna take your 2 numbers, make sure they go from least to greatest. So 9 on the left, 13 on the right. They are both less than, so whichever one is right next to the one on the left is gonna determine whether it's a parenthesis or bracket. So we're gonna have a parenthesis at 9. We're going to have a parenthesis at 13 and shade in between. This is saying x is between 9 and 13. The other way you can kind of see that, let me just write this off to the side. You don't have to write this down if you don't want to. This is just kind of explaining what happens here. If we look at the left side of this inequality, we have 9 is less than x, and if you remember, we can flip the 9 and the x around. We also have to flip the inequality so that the 9 is still on that closed side. And then the right part of our inequality here is x is less than 13. So if I write this one down over here, x is less than 13. Now, if we look at the graph, we want x to be greater than 9, so everything to the right of 9. But we also want x to be less than 13, so everything less than 13. But it has to satisfy both, because if I were to say, pick the number 14, well, that's bigger than 9. It's not less than 13. And if I were to plug in 13 or 14 in here, this is saying 9 is less than 14, which is true, but 14 is not less than 13. So I just like to think of this as x being between these 2 numbers, and it makes it really nice to graph. All right, so then interval notation is also super nice. Our furthest left endpoint is 9 with a parenthesis, comma, the furthest right we go is 13 with a parenthesis. And now these look like ordered pairs, like you'd graph on an XY plane. It's not the same thing. This is an XY point. This is an interval, just saying any number between 9 and 13, but not including 9 and 13, is going to be a solution to our inequality. All right, let's go ahead and try one more of these. And I'm going to do this on a separate sheet of paper here. There we go. Yep, number 2. Okay, so this one we're given -2 is less than -4x minus 5 is less than or equal to 7. So again, our goal is to get the x in the middle by itself. So if we look in the middle here, right now we have a -4x minus 5. So our goal to get the x by itself, we want to get rid of this -5 first. So let's add 5, and you're going to do it to the middle, to the left, and to the right. So -2 plus 5 is 3. Bring down the less than. Now we just have -4x in the middle, less than or equal to 7 plus 5 is 12. And if we go ahead and now see what we have in the middle here, we have a -4x. To get the x by itself, we're going to divide all three sides by -4. And if we do that, let me write this in here. Because we're dividing by a negative, we need to flip all two. I'm going to reword that. Flip both inequalities. So this less than here is going to become greater than. This less than or equal to becomes greater than or equal to. They're still going to be in the same position. So don't, flip them around that way. Just flip the direction that they're pointing. So we have an x in the middle. 3 over -4. -4 doesn't go into 3, so let's leave that as -3/4. 12 divided by -4 is -3. Now, anytime you divide by a negative, you have to be careful with your graph and your interval notation, because what happens when we divide by a negative is the left side is actually bigger now than the right side. -3 is more negative than -3/4. So you want to flip this around and put the -3 on the left, the -3/4 on the right. We know we're going to shade in between, so I'll do that. And then the only other thing here to do is figure out which one has a bracket, which one's a parenthesis. If we look at our two parts here, the -3/4 is next to the greater than symbol. And so that one gets a parenthesis. And the -3 is next to the greater than or equal to, so that's going to get a bracket. The other way to see this one, if we were to rewrite this, which you don't have to do, just make sure you flip these numbers around. We can flip this entire thing. We can put the -3 on the left, keep the x in the middle, and the -3/4 on the right. If you flip the entire thing around, you do have to move these inequalities. So this greater than or equal to is both going to flip and stay right next to the -3. Same thing with this greater than, it's going to flip, but it has to, oops, sorry, that's just a less than. It has to stay next to the -3/4. So this is technically what we should do with this one, but as long as you know to flip those numbers around when you're graphing it, that's perfectly fine to just leave it like this. Now our interval notation, again, getting that straight from the graph, we start at -3, we have a bracket, comma, we go to -3/4 with a parenthesis. All right, so that's it for section 8.1, a little bit of review. 8.2 is not review, but for the most part, it's not too bad. We'll be working with some set operations, compound inequalities, and then we'll see some absolute value a little bit later in chapter 8.